Hi everyone, I'm Norwish and today I'm here with Suraj to present our Lab 4 shape synthesis case study for the machine design lab. So we decided to study the typewriter, which most of you should know is a much earlier version of the modern keyboard, and it's used to speed up as well as standardize the process of writing documents to some extent. Also, the first official model was made in 1868.
Hey guys, it's Suraj here. So the inner workings of a typewriter are very interesting and unsurprisingly quite complicated due to the fact that we didn't have electromechanical systems back in the day. So over here is a key pressing mechanism, and just as a side note, there are many of these adjacent next to each other, and each of those correspond to one individual key. Just to get a feel of how powerful this mechanism is, we wanted to compare the input angle over here and the output angle of this whole mechanism. So the input angle here is the angle at which we push down, and the output angle is typically 90 degrees. As you can see from the animation, it's usually horizontal, maybe it's slightly less horizontal, and yeah, like it just becomes vertical. Okay, so to calculate this angle, we found that typically you had to push the key down by about 3/4 of an inch just to get the type to hit the paper. And the lever over here is typically 6 inches long. So using this, we were able to find the angle to be around 7.13 degrees, and that the geometrical advantage was around 12.6, which is actually quite impressive for most mechanical systems. Okay, so here are a couple of typewriter failures that are worth mentioning. The most common failure is the key types getting jammed together as shown here, which is hardly a surprise because there's so many mechanisms adjacent next to each other, as mentioned previously. So one fatal flaw of the mechanical keyboard is that it cannot accept multiple inputs at once, and yeah, that just causes a lot of jamming. This problem is really common. Like people will have to like reach into this place over here and like unjam it all the time. Over here we have the carriage being unable to move. So this carriage over here holds the paper, and as you type, it moves to the left so that letters get printed to the right of the paper. This is not too common as the keys being jammed together. As you know, like the chances of the keys getting jammed together is really high, especially if you're typing fast. The same cannot be said over here. So the reason why this happens is actually quite niche. It's usually just one screw being loose, and the screw could be anywhere actually. It's just due to how compact all the mechanisms are. Just one small error can cause this problem to happen. And the springs at the back also have to be reloaded, like after the screw has been tightened, just to solve the problem.
Hi, it's Norwish again, and next we will talk about shape synthesis principles in the typewriter. So there are many shape synthesis principles that clearly show up in the typewriter, and first I'd like to point out the key lever here has its right end sort of shaped in a triangle so that it could help in receiving loads. So yeah, this follows the triangle principle. Also, the lever itself is much longer compared to the other parts that are connected to it, as shown on the previous slide. So this follows the leverage principle. Finally, the last two parts on the right, we'd like to stipulate that they violate the metal removal principle. The segment here, this is attached to the back panel, and its function is to stop the key types when they reach the paper. So, yeah, we think that this semicircle shape could potentially be hollowed out to some extent, as well as this handle. Uh, Back in the day, it may have been due to manufacturing techniques, but they were typically made quite solid, and we definitely believe this can be hollowed out a lot to reduce the weight. Again, we'll be looking at the segment, but this time from a joint perspective. Me and Suraj really like the segment because not only does it have a lot of shape synthesis principles, or violations also, but it can also be treated as both a part and a joint. So, anyways, first of all, it clearly follows the mating surface principle, where this rather large area attaches to the back panel. However, it seems to violate the many small fasteners principle because there are some large and some small fasteners. In fact, in this small area here, there are actually three different sizes of fasteners. Yeah, just in this area.
Hey guys, it's Raja. So following the violations of the principles in the previous slide, that leads us to a design improvement recommendation for the segment in which only small fasteners are used. This should help in regards to both part stability and in procurement of parts. Another potential improvement is changing the key lever to a hollow cylindrical rod and using as many fillets as possible because the current design is to use rectangular prism shapes. This should in theory help with force flow. And this concludes our presentation. Thank you.